The bat math signal is up. I guess it's time to do some math. Good thing I'm here, because I'm Batman. Okay, I'm not really Batman. It's me, Mr. Quick, your teacher. But I can only imagine you're sitting at home thinking, I didn't know Mr. Quick knew Christian Bale, or was that Ben Affleck? I'm more of a Michael Keaton guy myself. But anyway, let's get on with it. Today we're going to talk about exponents. When you see an exponent, it might look something like this. You have a base number, and then you have the exponent. And we would read this as 7 to the third power, or 7 cubed. Let's keep going. When you see in exponential form 10 to the first power, it's exactly how you read it. The base number to whatever power your exponent is. So in this case, 10 to the first power. This exponent shows you there's only one 10. So the value of 10 to the first power is 10. When you see this number, you see 10 to the second power, which is also known as 10 squared. Since the exponent is 2, you know there are two 10s to multiply. So 10 to the second power, or 10 squared, 10 times 10, your value is 100. Here we have 10 cubed, or 10 to the third power. I don't care how you say it. Either way is right. That means you have 3 10s that you need to multiply. 10 times 10 is 100. 100 times 10 is 1,000. So your value is 1,000. And we're going to stop with this one, but we have 10 to the fourth power. That 4 as the exponent shows you that there are actually 4 10s. 10 times 10 is 100. Times 10 is 1,000. Times 10 is 10,000. So our value there is actually 10,000. The mistake I don't want you to make is seeing 10 to the fourth power and thinking, oh, that must be 10 times 4. No, don't make that mistake. It's an easy mistake to make. If you see 10 to the fourth power, that means you need to multiply 10 4 different times by itself. So 10, 1, times 10, there's 2, times 10, there's 3, times 10, there's 4 10s, and that ultimately gives us 10,000. Let's keep rolling. Let's write these problems in exponential form. Exponential form is just what we've been looking at. So let's see. Our number here is obviously 4, right? So that's going to be our base number. And our exponent is how many 4s are being multiplied. So we have 1, 2, 3. So in this case, we would have 4 to the third power. Our base is 4, our exponent is 3, so we have 4 to the third power, or 4 cubed. Down here, obviously our number in this case is going to be 9 as our base number, and our exponent, 1, 2, 3, 4, 5. 9 to the fifth power. Okay? Now one thing I do want to show you is this. This is 4 to the fifth power. This is 45. Don't make me guess what you're trying to say. Okay, let's find the value here. If we have 2 to the seventh power, okay, this one's going to be pretty easy, but there's always more steps involved than you may think. This shows me that there are 1, 2, 3, 4, 5, 6, 7 2's that I'm going to be multiplying here, okay? 2 times 2 I know is 4. Times 2 is 8. Times 2 is 16. Times 2 is 32. Times 2 is 64. And then finally, 64 times 2, if we do the math, 2 times 4 is 8. 2 times 6 is 12. 2 to the power of 7 gives us a value of 128. Okay, let's keep rolling. Find the value here. I know I'm going to have 4 6's that I'm going to be multiplying. Okay, 6 is my base number, so that's the number I'm using. 4 is my exponent, so I have 1, 2, 3, 4 6's. And this is one where we may have to do a little more math, and that's okay. Okay, 6 times 6 is 36. So I've used these two 6's. 36 times 6. I don't know off the top of my head, so I'm going to do the math. Okay, I'm using this 6 here. 6 times 6 is 36. Drop the 6, carry the 3. 6 times 3 is 18, 19, 20, 21. I'm at 216. I still have one more 6 to go. 216 times 6. Let's do it. 6 times 6 is 36. I drop the 6. I carry my 3. 6 times 1 is 6. Plus 3 is 9. 6 times 2 is 12. And I end up with 1,296 as my value of 6 to the power of 4. All right? Let's keep going. One last problem here. If Dana's school closes, a phone tree is set up to contact each student's family. The secretary calls 3 families. Each family calls 3 other families. How many families will be notified during the 6th round of calls? Okay, well, for this one, I'm going to draw a picture. And I'm going to say, actually, put it right in the middle here. I'm going to say that this is my secretary, okay? And she's going to make 3 different calls. So she's going to call, we'll use this circle representing a family, 1 family, 2 families, and 3 families, okay? So in the first round of calls, she called 3 families. Each of these families, okay, they're going to be calling 3 families of their own. You see how it's getting exponentially larger each time? It'll just keep getting bigger and bigger until, of course, they've called everybody. So in the second round, we have 1, 2, 3, 4, 5, 6, 7, 8, 9. They've called 9 families in the second round. I know you may not see a pattern yet, but if we look, our base number is 3. Because in the first round, they called 3 to the power of 1, right? There's only 1 3. In the second round, they called 9, okay? 3 times 3 gives us 9, all right? So 3 to the power of 2, or 3 squared, is our second round. So I'm going to go ahead and erase these drawings, and I'm going to write out what we just saw here. In the first round, we had 3 to the power of 1. In the second round, we had 3 squared. I believe, and I think you'll see as well, that when we get down to the 6th round, we're going to have 3 to the power of 6. So we're going to have to take 3 times 3 times 3. It's a funky looking multiplication signal there. Times 3 times 3 times 3. We have 1, 2, 3, 4, 5, 6 3's that we're going to be multiplying. And if you do the math, you'll be able to tell me how many families have been multiplied, or how many families have been notified, excuse me. When you do 3 times 3 times 3, then the answer times 3, then the answer times 3, etc., etc. When you're done, you're going to see that 729 families have been notified. Okay, here's what I'd like for you to do for me before the next time we see each other. Tell me, which has the greater value? 3 to the power of 4 or 4 to the power of 3? I'll look forward to seeing you in class.